Hi everyone, and thank you for signing up for this TÜVSÜD webinar on IEC 623681, second edition, and Outlook 2D, third edition. My name is Arlena. I will be your moderator today, and I will go through some basic information before we kick off with the presentation. Before we start, here's a quick introduction of the speaker today. We have with us Mr. Michael Hingert, who is Senior Product Specialist at TÜVSÜD. Mr. Hingert is a specialist in information equipment, specifically ergonomics, IT and office equipment, and electronics. He has more than 30 years of experience in testing and development of international standards. So with that, I will now hand the presentation over to Mr. Hingert, who will kick off with an introduction on the market overview. Mr. Hingert, please go ahead.
Good morning, everybody. So I'd like to give you a short presentation about this new standard in the IT area, and we'll have first a look on how was the development. So we all know they have the 950 and the 65 for such kind of products, and there was an idea from the European computer manufacturers there we have a standard which is hazard-based. So the first edition of this European Computer Manufacturers Association standard, the 287, was in 1990. And if you compare this standard to the today's standard, there was around 80 pages, not more. So when we have the second edition in 2002, and then there was a decision that we have to go for an IEC standard in this area. And you see there's a very long time between 2002 and 2010. So it was a lot of problems to set up the standard, and the TC108 have break down several times the rules for the timing of the standardization. So in 2010 we have the IEC version of the standard, was approved for the IEC world, but in Europe there was not accepted at this time. So then the TC works with very high pressure to get a second edition, and we have this second edition in 2040, and this is also accepted in the European countries. And there was then we work on the new edition, the third edition. So the next stage of the third edition will be FDIS, and I expect it maybe in December of this year, and so we can have a third edition if everything runs smooth in 2018. So this standard was then listed, which is interesting for all the manufacturers, under both category in the CP scheme. So you see here that's listed under the category off and run, so that we can provide test reports and certificates for this standard in the IT world. So what is the standard? So the idea behind this was there is no merger of 65 and 950, so we like to have something new. There shall be hazard-based, technology independent, and based on sound engineering principle. So that was the idea. And if we are look today in the standard has around 350 pages. And we have also a rationale for this standard with 200 pages, so that shows that this standard is not easy to handle. And we will see how far we are fulfill this goals, what was from the beginning here. So the idea is for hazard-based standard clearly to identify the hazard which we addressed. So we have clearly states principle. So the basic regulations, that means we have to look very deep into our basic requirements and pilot standard in this area. Use the vocabulary and the definitions and so on. And there was a move into a user-friendly manner. That was always the goal, also for the 950. And you have to make the decision if we reach this goal or not. So I have sometimes doubts about this. So we will cover all specific hazard. So that is the reason that this standard is called hazard, and different hazard areas. So for example, mechanical hazard, radiation hazard, we'll see later. And the hazard will separate in sections. So that means each of these hazards has its own section in the standard. Include this rationale, I mentioned this, so that was that we have 200 pages of this rationale, and they introduced the 3-block model for the principle of safety. And the new part is from this standard between, well, if you compare it to the 950 and the 65, you have learned a new language. So they use different terms for maybe well-known things. So we have energy sources, we have energy transfer, we have safeguards, and we will say later on how we deal with these new wordings. So first we have a short explanation of what is a hazard or hazardous. So we take the part from the guide 51. It's a potential source of harm, and safety is the freedom of unacceptable risk. So you see here in this guide 51 we have this 3-block model also. That means the step 1 is interior safety design, means the product is safe by themselves. If this is not possible, then we came up to guards and protection devices, and if this is also not possible or fulfill everything, then we have to go to step 3 to give information for use which prevent the user for any hazard. So this is a 3-block model. So we have a hazard energy source, energy sources capable of causing pain or injury. So that it's the one time. Then we have for each of these different hazards, we have a transfer mechanism, and we have the body. And then we have a classification in 3 classes. So the class 1 is no pain, but maybe detectable, but no ignition and something like this. So if we go to the class 2, it's painful but not injured. And then we have the class 3, it's injured, and then we have all this hazard which come up with spread of fire and something like this. So how we have to deal with the energy with class 1? So we have a limit for this. That means this shall not exceed under normal operation condition, abnormal operation condition, and single fault does not result in class 2, higher than that 2. So that's the point, and we have to look for this carefully for these conditions here. So the new thing is a little bit, the normal condition is clear. Abnormal operation, it's different to a single fault condition, so that means we have maybe locked openings for ventilations or something like this. Next. So energy class 2, it's the energy which exceeds the class 1, but not exceed the class 2 limits. So we have limits for class 2 for each of these hazards, and we cannot exceed them. But the difference is here, you cannot exceed these limits under normal condition, abnormal, or single fault. It must be still the same class 2 limits under all these 3 conditions. Energy class 3 exceeds the limits of class 2 under normal operation condition, abnormal conditions, and single fault, and any energy declared to be class 3 source. So this is the part here. So we are in the section 4 of the standard, which gives a general information how they deal with these classes. If we go later on to the section of the hazard, So maybe they make more clear or have slightly different regulations on this, but this is the principle which we have to follow for all these other hazard sources as we go into the standard. So there are the list of the energies which we addressed here. So there is electrical energy with ES. So we have thermal energy, so chemical reactions. So the kinetic energy, that's the mechanical part, thermal energy, hot surfaces, and we have the whole area of all this radiation energy, which we have also to address. You see here the subclasses, so if we jump from 4 to the next one, it's 5, 6, 7, 8, 9, 10, they address all these different energy sources. So we came to the new word safeguard. So that's the same thing from the ISO guide here. So we have the 3 steps. So equipment safe is always useful since they do not require any knowledge of or action by the person. So that is fine. That to things like if we have enclosures which are decided for each different of the energy sources. So then we can have maybe installation safeguards. Maybe we have a fan around some of the equipment. It's one of the possibility or other things. And the other part is behavior safeguard, which gives information how we can use safe this equipment. So the system and the 3-block model is here. So we have the hazard energy source, then we have a safeguard, and then we have the body. So that is the point how we prevent the user from a hazard energy source if we put in between, to interpose between the source and the user a safeguard. So if we go back to the 3 classes of the sources, so we have class 1, no hazard energy source, so there is no safeguard necessary, so you can have access to this, can touch it, it's no problem. If you go for the next one, that we say, okay, we have a hazardous energy source, and so then we need a basic safeguard and a supplementary safeguard between the sources and the body. You see here they use safeguard, but I think maybe you are more familiar with the wording basic insulation and supplement insulation, but this is only one kind of safeguard that you can use for this. So it's more, the wording is more generic in this case. And we have the same part here, by a single fault condition must still safe. And I think that it's also normal and no, we can have also a reinforced safeguard between the hazard energy source and the body, and that must be a robust safeguard that is effective under normal operation, abnormal operation, and single fault condition. Okay, here's the overview. So we have a person. I will explain later on what is the difference between ordinary and skilled and so on person. So energy class 3, so we can have a reinforced safeguard. So at the energy class 3, it's also possible that we split this, that we have a basic safeguard and a supplementary safeguard. And for the energy class 2, for the ordinary person, we have a basic safeguard in the post here. So we have the instructed person. So then we can say, okay, we have a basic safeguard and supplement safeguard for energy class 3. And you see here the difference if the person is instructed that he knows which is the hazard. So maybe it's possible if you have the energy class 2 that you can work with a behavior safeguard for this group of persons. And if we came to the specialist, the skilled person, so he needs a skilled safeguard in both cases, so that can be insulation, that can be behavioral safeguard, something like this. You see here also in the table which things are needed, a number of safeguards between the interpost between the sources and the person. So then I think the critical or the most time-consuming part is to identify all the sources that you have in the equipment. So that it starts in this case that you have to identify is this source in PS1, 2, or 3, and you have to do this the same for PS1 and 3, so MS for all this 5 kind of different energy sources. So that's the one thing. Then you have to start, okay, if we go to the flow chart, identifying, we do this, so we find out is this energy, what kind of hazard energy source is it, then we have to thinking about the transfer mechanism to the body part. So if we find out the source is not hazard, so everything is fine. If we find out is hazard, then we have to look in which way is the energy transfer to the body part. And then we have to check the design of the safeguard, which is interposed between the energy source and the body part. And we have to check is the safeguard effectiveness in this way that is used in the equipment. If everything is fine, then this part is done. But keep in mind, we are talking about several hazards, and we have to do it for each hazard separately. That's the point. Okay, I will step a little bit in the energy, electrical energy area. So as I mentioned before, this standard is 350 pages. So I can only for 45 minutes, a small part of them. This is a short overview. What is the difference between 65950 here? And so you see we have different voltage, which is used for the scope. So 65 is bigger than 35 volt, and 950 and 62 to 68 is more very consistent. And to 65 we have no class 3, but this is new. We have now this class 3 equipment too, and there's also a little bit different in the working voltage, but I think it's very similar to the 950. I think that was interesting part is here that we have in the 962 the mains is AC or DC in the distribution grid, and this is more clearer now. Operation mode. So you heard about before that it's a little bit different between these 3 standards, and we have an Annex B now, which gives the normal operation mode condition, abnormal operation before for the different part of safeguards, etc. It's more clearer here than before. Ordinary person, this is the user of the equipment. So we have access to the equipment, and we have to have between the hazard energy sources safeguards that he cannot get pain or injured. But we go now to the instruction person. So they get is instruction and trained by a skilled person. That's the only point. And is under the supervision by a skilled person. Then he can do a little bit more on this kind of equipment. If you think about, we have a big copy machine, so he can do some change of some parts. Then he has to need the instruction from the skilled person that he can do this. But keep in mind, we have still the safeguard between class 2 sources in this equipment. And the skilled person is have a training or experience in the equipment technology, and he knows what he's doing, but I think there will be more clarification in some countries what is the understanding for a skilled person. Okay, telecommunication network. So we have different terms used in 65950, and now we have only external circuits, which is all the things what is coming from the external side. I can give you one hint. There is a table W.3 where you find a comparison of the terms and definitions between 950 and 6268, which gives you a better idea what is the meaning by the ID numbers in the table 13. And as we discussed before, we have the energy transfer. So you see the person here. So we have the energy source, electrical one. He touched one part and he is connected to the ground. So the body has a good connection in this case. So we have two contacts. So we have a prospective touch voltage or a touch current and the two contacts. And then we have the body, which is given in the body resistance. So this is coming from a standard called IEC TS, Technical Specification 6479-1. And this was the first idea that was if we like to use all this pilot standard in this case. And then we came to this table G1 from this standard, and you see here that we have different resistance capacities and so on. And the important point was that this time we have to define large array contacts and so on, medium contacts. So that means we have for each accessible part have to check the size of them, and then we can say what is the maximum voltage or current which we can have on this. That was in the beginning, and then they make a decision, okay, we like to stay with the old values from the more or less from the 950, which is easier. In this case, we gave up to follow strictly this technical specification. But we'll see later on, we have in some areas, some regulations where we have look also for the size of the touchable areas. So you see here what we are talking before, electrical energy source. So we have the prospective touch voltage and touch current. Then we have a safeguard, maybe an insulation, and we have the body resistance there. And then you see here what is the definition for ES1 for the electrical source. That's the same that we saw before. That means we have to stay by the limits of ES1 under normal operation condition and abnormal operation condition. Single fault, then we have to check that we cannot see the ES2 limits, and the single fault of a basic safeguard. That means if we can bridge a safeguard or something like this, that shall still remain to ES2. The same as before we have for ES2 and ES3, as we mentioned in the section 4. New things, what we have here is we have a new probe. You see here, this is on the right side, on the top. This is a probe which is used in the US for a longer time. So the reason why we use this probe here is that this probe more representative the average of the humans in the world. So the IEC test finger was a little bit more related to the human side. So this one is different to the IEC from the dimension. So if we go for 65, so we have 35 peak or 60 volt DC, or for the professional apparatus, so we have audio signals which are higher, and if we go for 950, so we have the 42.4 volt peak or 60 volt DC. And this is changing in this standard. and sorry, first this is here. So, and we have in 950 the limitation for the current peak by 0.7 milliampere and 2 milliampere DC, or depending on the frequency of the voltage, it can goes up to 70 milliampere peaks. If we go now to the 62 to 68, then we see here we have still the 30 volt RMS or 42.4 volt peak, and we have also this calculation where we came up to higher values if we have a frequency up to 100 kilohertz. So this is clearly the same. So they have this combination here, which you can calculate all the AC and DC parts. And you see here in the table on the box, there's a link to the IEC TS 6049. So this is one of the areas, one of the part in the standard which we make a limitation about to the accessible area. You see here above 22 kilohertz. So there is a limitation to 1 centimeter square, which you can touch. Otherwise, it's not allowed to use this value. So we are introduced in the 950. There is a network from 990. So we have a very strong link now to the 990 for all the testing. And we have introduced the figure 4 and the figure 5 in it. You see it here. Both figures are in now. And the interesting part is here, if your touch current has not a sinus waveform, then we have to use a measurement equipment for this, which can indicate peak voltages. Otherwise, if it's a sinus waveform, then we can use RMS instrument as we're used normally. It's a different here. Okay, so this is the part from the discharge of plugs. So we are from the 65, so we can go up to the limit to 0.1 microfarad, and they use 2 seconds. And we have 950, which also use nominate capacity not exceed 0.5 microfarad. But for pluggable type A, we used 1 second, and for pluggable type B, 10 seconds. This is a little bit different now. Come on. So we have this table where we have to check where we are. So that means here we have 91 nanofarad. So this is acceptable, and otherwise we can higher. We have to have the 2 seconds. What is missing in this table? So maybe you know this special discharge IC, which you have now in the equipment. So that we can have the situations that we have maybe nearly 2 seconds the higher voltage, and then it shut down. So I think we have to do something in the standard for the future, how we handle this. Okay, and here are the limits again from the 950 here, so we have to compare. It looks like a little bit more stringent. Insulation materials, so it's a choice and application of commercial count the need for the electric terminal for all this. Then we have to check, is it okay on this component, and it must be robust as a safeguard. So we have here the temperature list, and you see here material or IES system. So we have to keep in mind that we have to look carefully now for our IES system. This is different from the 950. So in the 950 we are live with approach that we say, okay, the lowest terminal class will be chosen for the whole system. So now we have to do an evaluation on the transformer system that this fulfills the IES system. This is also new. They give some information how what we can consider as stable temperature. So that means here, so not exceed 3 Kelvin in 30 minutes, or okay, 1 Kelvin in 5 minutes. That's new, was not in the post standard. Then there was the difference between 65 and 950. 65 used the V-cup test, and 950 used the ball pressure, and so they bring in both possibilities. Then you can use the V-cup or the ball pressure test and the new standard. This is a flowchart how to determine clearances. So it's a little bit complicated written, but you see here, if you know a little bit the 60664, that you will find several things which are familiar with this. So we have to check first which kind of voltage can we have. So we have to determine the clearance from the IEC or temporary overvoltage. Then we have to look for peak value of most unfavorable supply voltage, and we have to look for the recurrent peak values. And if we go for this, then we came to the situation that we check for circuits where both frequencies 30 higher and lower 30 kilohertz and higher 30 kilohertz, then we have to go to different parts. So we have different tables in this case. And then we get from all these three areas, we get information about the clearances, and then we have to compare the clearances in this case. If you have here the recurrent peak value, then you have to check carefully which recurrent peak value can be in your equipment. So that means you have to check, maybe you have different recurrent peak values by different frequencies. Then you have to look which one is the highest and which has the biggest influence to the clearance. So this is the one way. And the other way is, okay, we have to go for the transient and find out what's there. Then we can choose the test that came to the other point. But this is strictly the approach from the 6064, but was not word by word transferred to the standard that maybe sometimes create problems. So this is a table here for frequency higher than 30 kilohertz, and keep in mind this in the bottom line here. So this table takes not into account influence from tracking phenomena. So we have to go back to table 18 in the case that the values of table 90 are too low. Humidity, so we have in 65 the tropical one that was not covered by the 950. So we see here now we have also the tropical one with the 40 plus minus 2 degrees Celsius in the standard. Okay, and I'd like to have give you a short outlook to the third edition. So this is an overview what will be happen in the third edition. So there's one thing with outdoor equipment, optical radiations was touched, liquid insulation, it didn't work for work cells, wireless power transmitter, fully insulated wire, and we have to modify a little bit the enclosure requirements. So let me step in. The first thing is, it's important for 950, we have two standards called, one is 60950-22, which was for the equipment and outdoor locations, and we have the 6950-23, which was for the large data storage. Both standards will be coming in the third edition in the body part of the part 1. And this is the other topic which will be discussed many times, and the topic here is what should we do with already tested and accept components for 95065, and the idea was the second edition that we have in here a paragraph that we can accept components. In this way, can delete this section with the third edition, but it will put in something in the direction in the next revision. So that can be only a problem for the national committees in Europe. So we have a sharp line that we have transition period ends for 65 and 950, and then we have no longer the standard as a legal standard. So I will clarify what's going on with this. Maybe we have to change something in the European area for this. Interesting point is also that the change from product contain lithium coin and pattern cell, and will bring in now that will every battery, not only lithium. This is a change what we have. And they give a requirement about the torque for checking the openings on battery compartment. So this is a funny picture. So you see here there's a motherboard with a liquid inside. So this liquid inside shall be used for cooling purpose. And so this will be a new section in the standard, in the third edition, which deals with insulation liquids, what the requirements, breakdowns for this, etc. So that it's new, and we have something inside here now. Okay, this is a funny thing already. I think that it changed a little bit by the wording. If you have maybe your power supply for the laptop computer in front of you, and you have this plug with ground connection, then you can have always the problem is now my whole plastic covered power supply bracket is a class 2 or a class 1, and so you can now say, okay, this is a class 2 equipment, then you have to use the ground from the plug and from the main plug as a functional earth. Or you can also say it's a class 2 equipment, then you have to look in both sides very carefully about distances on the appliance inlet. So the appliance inlet normally constructed for class 1 equipment, and maybe if we have decided that we say, okay, we have a functional earth on this class 2 equipment, then we have to, on this part is touchable, so then we need a reinforced safeguard between this functional earth and mains. Okay, new requirements here for all this wireless power transmitter. And this part you see here, that's a mobile phone, you can charge them, so there are some tests now in for temperature measure and so on. So this will be covered with the third edition. This is about the radiation energy source classification. So there will be more detail in the future and give you more different standard for this. So in the former times, for example, if we have image projectors, then we have to follow the 62471-1. Now we have the possibility to go for the -5, which helps us that this image projectors fulfill the requirement for the radiation energy sources in this case.
All right, thank you, Mr. Hingert, for this insight. We really hope that you found this session interesting and relevant. So we have several webinars in the pipeline. So do sign up for our Consumer Products and Retail Essentials newsletter. You can do that at the website www.tusuit.com/CPS. So you'll get the latest news, regulatory updates, and more. And if you have any questions regarding this webinar or what we do, just feel free to email us at cps@tusuit.com. So for the rest, thank you for your time and have a good rest of the day ahead. Goodbye.
Bye-bye.
Bye.